So we're currently focusing on problem 14, A through F, true, false. Sometimes these can be kind of tricky, so you got to be careful. So by using the properties of logs, we can take, looking at part A here first, we can move the 4 to the exponent position. Let's go ahead and do the work for that down here. So we would have the ln of radical e, which I'm going to write as e to the 1/2. So we have radical e, or e to the 1/2, raised to the 4th power. Now the question is that equal to 2? Well, if we take e to the 1/2 to the 4th power, that is e to the 4 times 1/2, or 2. And indeed, ln of e squared is 2, so that would be true. All right, now for part B, we have 2 times, so we're going to do the same thing. We're going to take that ln, and we're going to write the argument as 7 to the 1/2 times x, and we're going to raise that argument to that 2, and then what happens there? We get ln of, now 7 to the 1/2 to the 2nd power is 7 to the 1/2 times 2, which is 7, and then x to the 2nd power is x to the 2nd power. So that is also true. All right, and then part C, that's just false. If you have two ln's here, you just have ln of 20 over ln 5. It's not ln of 4. The proper way to write that is the ln of 20 over 5 is the ln of 4. Okay, it's not ln of 20 over ln 5. And then this one here, so we have a 1 times ln x plus 2 times ln x. That's 3 times ln x. That's true, for sure. And then log base 2 of 33, well, is between 5 and 6. Yeah, 2 to the 5th is 32. 2 to the 6th is 64. So that's also true, between 5 and 6. And the range of the log function is not all real numbers. That has to be false. So that's false. All right, let's look at 15. All right, so 15, I'm going to take a little bit of analysis here. So you've got a log base 3 and a log base 6. Now, which is which? Okay, so let's do an XY chart for the log base 3 of x. Okay, so y equals log base 3 of x. They both hit 1, 0, so we can't figure out, there's nothing we can determine from that because they both go through that point. What we want to try to figure out here is if x is equal to, let's say, 1/3, I'm going to write that right like that, right like that, 1/3, and then x is equal to 1/6. Clearly 1/6 is less than 1/3, so that would be a good, those would be two good numbers to put in there. In fact, 1/3 is the same as 3 to the negative 1, and 1/6 is the same as 6 to the negative 1. So that's helpful. So in other words, if x is equal to 6 to the negative 1, actually we're looking at y equals log base 3 of x, so let's not use 6 to the negative 1, let's use 3 to the negative 1. So if we replace x with 3 to the negative 1, then we have the log base 3 of 3 to the negative 1, which is just negative 1. All right, now negative 1 is right here. Okay, and so it would be likely that this graph down here is y equals log base 3 of x. Okay, let's just double check and see about letting x equal 6 to the negative 1. Well, if x is 6 to the negative 1, and we are plugging 6 to the negative 1 into the log base 6 of x, then we also get y to be negative 1. So if x is 1/6, then we go down to negative 1. So we could see these guys here, the graph that's up on top, let's see, which is which. Okay, so the one on top then would have to be y equals the log base 6 of x. And just for those same reasons that I just said, if you plug in 6 to the negative 1 into the log base 6, then it's higher than if you plug, or it's at the same height as if you plug 1/3 in to the log base 3 of x, and those are the same. And the only way for this to work is if the log base 6 is the one on top and the log base 3 is the one on the bottom. There are other ways you could explain that as well if you think about it. the log base 6 is going to be closer to the axes, but that's what the reasons are. Those are the reasons why. If you want to know where the graph is, you just plot some points and would show where how high or how low the graphs are at those certain values of x that you plug in. All right, now we're at 5 minutes, so let's go ahead and make a new video for the next set of problems.